All right, in this lesson, we're going to talk about exponential growth and decay. Before we get into that, I do have a what's it type puzzle. Take a guess at that, and I'll tell you the answer at the end. Okay, so if we're talking about exponential growth and decay, we're talking about a function that has a variable for an exponent. So, for example, it could be this, y is equal to a to the x power. Or maybe something that looks like this, y is equal to a times b to the x power. And if we're talking about the growth portion of an exponential function, so both of these are going to look something similar like this. So as our x numbers get larger and larger, our y values will grow exponentially. So they will grow very, very quickly. All right, so let's actually look at some values, some table values, and then we'll try and plot this and look at it graphically. Let's look at this function here. So y is equal to 2 to the x power. So just note that I let a equal 2 in this example. And we're going to make a table here. We're going to build a table using these values. So let's do -1, 0, 1, and 2. Let's actually start here at 2. So I think this would be the easiest to figure out here. So if x is equal to 2, we're going to substitute that in there. So 2 times 2 is 4. All right, so let's continue with that idea. Let's plug in 1. So 2 to the 1 power, that's just 2. 2 to the 0 power, and you guys know by now that any number to the 0 power is equal to the number 1. Now, when we start to plug in our negative exponents, this is just going to move the 2 into the denominator. Hopefully, we've done enough of these by now that you can look at this and say, oh, it has a negative exponent. So this just needs to go in the denominator. That's all it is. So we really get 1/2. And if we started to plot these points, so let's start down here. If x is 2, y is equal to 4. If x is 1, y is 2. If x is 0, y is 1. And then finally, if x is -1/2, if x is -1, y is positive 1/2. And if we connected the dots, our graph would look something like this. And notice that our negative x values, they're approaching what line? If you said y is equal to 0, you're correct. They actually never ever, our function here is never ever going to cross y is equal to 0. So this is actually called an asymptote, and we'll get into that later. So our range on this one would be, so remember, range is just all of the y values, right? So this one actually goes from 0, right? So all the way down to 0 to positive infinity. What do you think about the domain? What's the domain? Can it be all x values? Well, it turns out, yes, we can plug in anything for x. We are not restricted at all. So we can have all of the negative x values, so all the way to negative infinity and all the way up to positive infinity. Okay, so let's look at a different function that might be decaying. All right, we're going to start with a fresh screen here, a clean slate. And this is the function that we're going to work with this time. And I'm going to say it might be decaying, might be a decaying function, but we're going to use some x values and see just exactly what happens here. So note that our a value is 2. What's our b value in this one? B is actually equal to 1/2 in this one. All right, so let's use these numbers here. So -2, -1, 0, 1, and 2. These are kind of the classic 5 that we want to use for test values for x, and then we're going to figure out what is y when we plug all that stuff in. So let's actually start down here at +2. This is always the easier, I think, to do. So we have 2 times 1/2 squared. So I just substituted in 2 for our exponent here. And so this would be 2 times, well, 1/2 squared is a fourth. So this is actually equal to 1/2. So this is equal to 1/2. Let's continue with that idea, and let's do if x is 1, what's y? Okay, so let's see, 2 times 1/2 would just be equal to 1. So we have the number 1. And then let's see, let's do 0 to, let's see, times 1/2 to the 0 power. And you guys know that anything to the 0 power is 1. So we really have 2 times 1. So 2. And then here we start to get into negative exponents. So let's do -1. So 2 times 1/2 to the -1 power. And again, hopefully we've done enough of these that you can recognize that this 1/2 goes in the denominator. So we really have 2. So our 2 stays in the numerator, okay? And then we have our 1/2 goes in the denominator. Now in this we have to do the keep, change, flip method because we have a fraction in the denominator. And we can't have that in mathematics. So we're going to keep the 2, we're going to change the division to multiplication, and then we flip the denominator. And then so it's just a multiplication problem now. So it's 2 times 2, 4. And then we have one more left to do. We have 2 times 1/2 to the -2 power. Again, we're going to do the same thing. This is now in the denominator. So over 1/2 squared. And then let's go ahead and simplify this out a little better. So 2 over, let's see, 1/2 squared is 1/4. So we're going to change the division to multiplication, and then we flip the denominator. So it's 4 over 1. So we really wind up with 8. And let me just point something out real quick. I think some of you might have difficulty just because of this example right here. So this right here, maybe some of you wanted to combine this, so 2 times 1/2, maybe you might got a 1x here. So we can't actually do that because this x is a variable in the exponent. So it's an exponent. So you actually cannot combine the 2 and the 1/2. So I just wanted to point that out just in case. All right, so let's start to graph some of this stuff. So let's do our first point here. Let's do 2, 1/2. 1, 2, and then let's say 1/2 is about right there. And then let's do 1, 1, about right there. 0, 2, maybe about right there. -1, 4, so maybe about right there. And then lastly, we have -2, 8, so something way over here. And if we connect the dots, if I can get the pen to work here, our graph would look something like this. And when we started this problem, I asked you, is it a decay function, or could it possibly be a decay function? And it turns out that yes, this one actually is a decay function. And my question to you is, why? Can you maybe come up with some reason why it would be a decay function and not a growth function? Well, there's a special property when we're using this right here. If b is in between the number 0 and the number 1, so a decimal in between 0 and 1, it will always be a decay function. That's just a property that this type of equation has. So if this b value is in between 0 and 1, it is a decay function.